So today we're going to learn about law of cosines. Last class we learned about how to use law of sines in order to solve for missing sides and angles of non-right triangles. Law of cosines is used more so whenever you have side angle side as well as three sides, which we write as side, side, side. The important thing to note is that side angle side must have the included angle directly in the middle. So for law of cosines, we have to know certain parts in order to find either you can use it to solve for missing sides or missing angles. So the first formula that we are going to discuss is if we would like to solve for the value of side A. Remember that the sides and angles are opposite each other. So we're going to say that A squared is equal to B squared plus C squared minus 2 times B times C times cosine of angle A. The second formula, B squared is equivalent to A squared plus C squared minus the product of 2 times A times C times cosine of angle B. And lastly, C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. Now, do not get overwhelmed by the complexity of these formulas. Realize that it's as simple as substituting the values that you're given in your triangle and also using your calculator in order to find the value of either side A or angle or its corresponding angle. Again, when do we use the law of cosines? You can use the law of cosines to find missing measures in any triangle when you know the measures of two sides and the angle in between them, side, angle, side, which looks something like this, right? You know one side, you know the angle in the middle, and then the other side. The most important part is that included angle directly in between the two sides, as well as if you know three side measures. So let's go ahead and let's try this first example. So in this first example, we're going to talk about how to find missing sides. Okay, so here we're given a triangle where we have that scenario of side, angle, side. So I know I'm going to use law of cosines. So we are going to need to find side x. So one way to start this is I'm going to go ahead and label all around my triangle. I'm going to label A, B, and C. It's quite arbitrary. And then I'm also going to label my side. So that means that X is going to be side A, 23 will be side B, and 9 will be side C. So once you figure out what you need to look for, which is I'm going to need to look for side A, correct, because that's where we have that X, I'm going to need to use the formula that defines A. So I'm going to use A squared equals B squared plus C squared minus 2BC times cosine of angle A. Okay, so one thing that I like to do is I just like to make a little key that has the specific measures. So for example, B is 23, C is 9, measure of angle A is 71 degrees, and I'm going to label little side B, little side A as x, since that's what I am going to be looking for. After that, all I'm going to do is simply substitute these values into the formula. And every time I substitute, of course, it's important that I do use parentheses. So I like to first set up my problem with the proper parentheses. So that I know everywhere that I see b, I'm going to substitute that 23. So I'll go ahead and color code this. So everywhere that I see b, I'm going to substitute this 23. So here is b, 23. Also 23. I'm going to substitute c, which is going to be 9. And then, of course, angle A, which is 71, which I'll place right here. And, of course, being that A is x, which is what I'm looking for, I will replace that right here. Okay. So at this point, what I'm going to do is I know that in order to solve for x, I'm going to take the square root of both sides in order to isolate x. So now, since x squared and square root of x is inverse operation, I know that I've isolated x. And believe it or not, I'm going to take the square root of everything that I have written above. Now you may be asking me, why am I rewriting the expression above? Well, that's because I'm going to use my TI 84 Plus calculator to enter in all of this, and in order for me to actually find what side x is equal. So I'm going to go ahead and enter this exactly as how it's written into my TI 84 calculator. And when you do that, you should get approximately, let's see here. Remember, we're going to round to the nearest tenth, so I'm going to get approximately x equals approximately 21.8. And that is the value for x. Now go ahead and pause this video and try this on your own, problem number 1, just to see that you understand the material. And press play whenever you feel ready to check your work. Okay, so for this problem, you should have labeled your triangle. I'm going to go ahead and make this a little bit bigger. So for me, I just labeled, I went A, B, C, and I labeled the sides A, B, and C. And so since X is side C, I use the formula in order to find that side C. So C squared equals A squared plus B squared minus 2AB times cosine of C. And again, I went ahead and I made a key with the information I need in order to evaluate and find side X. So from the diagram, I'm able to pull that A is equal to 17, B is equal to 15, C is equal to X, and angle C is equal to 39. So I'm going to substitute. So C squared is equal to 17 squared plus 15 squared minus 2 times 17 times 15 times cosine of 39 degrees. Now, hopefully you took the square root of both sides in order to isolate C. And when you enter that expression above into your TI 84 calculator, you should have gotten a final solution of 10.8. Oh, which is denoted with x. So, of course, that's x equals 10.8. So if you got 10.8, good job. Let's go ahead and move on to example 2. So here we go. We're going to solve for an angle. So that means I'm going to have to use my inverse function. So I'm given this scenario here, which I have side, side, side. And it's side, side, side because I'm given 3 sides of this triangle. So I'm going to go ahead and I'm going to label my triangle, which is quite arbitrary. So I'm going to, let's say I call this angle A, B, C. And then, of course, the sides opposite, I'm going to label. 10 is going to be my A. 11 is going to be my B. And 8 is going to be my side C. And I'm just going to erase the part where I put that side, side, side. I just don't want to get confused. There we go. Then I'm going to make my key. And I'm going to just check and see what it is I'm going to have to look for. Since X is angle C, which is opposite side C, I know I'm going to have to use the formula that shows that we can find that C. So I'm going to use the formula C squared equals A squared plus B squared minus 2AB times cosine of angle C. Now for this problem, let's go ahead and substitute, and then we will discuss how we will solve for angle C. So I'm going to substitute. Again, you can also make a note of those sides and angles that we are given, or in this case, all sides. So A is 10, B is 11, and C is 8, and angle C is X. Okay, so C squared, I'm going to go ahead and I'm going to place 8 squared equals 10 squared plus 11 squared minus 2 times A times B, which is 10 times 11, times cosine of C. I'm kind of crashing into this figure here. So I know this looks very complicated, but students, what I would like you to do is we're going to solve for C, but we're going to want to isolate cosine of C first. So it's really important that you use order of operations to simplify this in an ordered fashion. So remember our order of operations, we have parentheses, exponents, multiplication or division. Remember, you move left to right whenever whatever operation comes first. And then addition and subtraction will be your last movement. So here, we're going to simplify or evaluate these exponents first. So 8 squared is going to give me 64. 10 squared is 100. 11 squared is 121. And then lastly, I'm going to complete the multiplication here. So I know that negative 2 times 10, that's negative 20, times 11. There I'm going to have 220 cosine of C. Now it's very important, students, that you be careful. You're not going to take the difference of 121 minus 220. You're first going to have to take the sum of 100 plus 121. Recall that addition, you're going to complete your addition before subtraction, or if you have them both, move from left to right. So I'm going to put parentheses around this 100 and 121 just so I can make sure that I complete that calculation first. So when I do that, I get 221. I have equals 64. And then I'm going to bring down minus 220 times cosine of C. Now I'm going to solve this like a regular equation. And I'm going to subtract 221 from both sides. And that cancels. And when I do that, I get negative 157 equals, that cancels, so I'm going to bring this down, negative 220 times cosine of C. Since I want to isolate cosine of C first and then take the inverse to solve for C, I'm going to divide both sides by negative 220. And that will give me cosine of C equals, and once I place this into my calculator, I'm going to make sure that I round it to at least 4 decimal places, which will give me 0.7136. Now, in order to isolate C, it's important that I take the inverse cosine of both sides. And that ends up canceling that out. And now I have C is equal to the inverse cosine of 0.7136, which gives me C is equal to approximately 44.5 degrees, which should be right here, 44.5, which is that X as well. Let's go ahead and move on to the second on your own. So for on your own too, go ahead and pause this video. Try this example. Use the example that we just went over and try to solve for the measure of angle X. When you're done, go ahead and unpause this video so you can check to make sure that your solution is correct. Okay, so for this problem, it's the same concept that we did before. I'm going to go ahead and I'm going to label A, B, and C for my angles, and then the sides opposite that. So 16 will be side A, 13 will be side B, and 5 will be side C. Now, since I'm going to need to find angle A, I'm going to use the formula that best defines that angle A. So I'm going to use A squared equals B squared plus C squared minus 2BC times cosine of A. Now I'm going to substitute those values, and I'm going to have 16 squared equals 5 squared plus 13 squared minus 2 times 5 times 13 times cosine of A. I'm going to first simplify my exponents, and I'm going to get 256 equals 25 plus 169 minus 130 cosine of A. And then I'm going to simplify the sum first. So I'm going to get 256 equals 194 minus, bring down that 130, negative 130 cosine of A, or minus 130 cosine of A. Then I'm going to subtract 194 from both sides. And I'm going to get 62 equals negative 130 cosine of A. I'm going to divide both sides by negative 130. And that has me isolate that cosine of A. So on this side, I'm going to have cosine of A equals, and then I'm going to do find the quotient of 62 and negative 130, and I get negative 0.4769. And lastly, I'm going to take the inverse of both sides in order to solve for angle A. So I'm going to go over here, and I'm going to simply put angle A, or A, equals the inverse cosine of negative, I don't know why did I put that negative in front here, negative 0.4769, which gives me a result of 118.5, which is x as well. So if you got 118.5 for x, you are correct. Okay, go ahead and pause this video and try the third on your own. Now this one is a little bit different because you're just going to have to draw your figure first, and then you can perform the calculation as we did before. Okay, so for this problem, I went ahead and I just drew a random triangle, and I labeled it LMN. And since we're using different variables instead of A, B, C, I can treat my L as my A, my M as my B, and N as my C, correct? So I know I'm gonna try and use my little lowercase l squared equals, right? Or N squared equals, or M squared equals, to fill in the rest of the formula. Okay. So I'm going to go ahead and I'm going to use the information given, and I'm going to label my triangle. So they're telling me that side LM is 25, side MN is 20, and side LN is 24. And they want me to find the measure of angle L, which means I'm going to need to use the formula for L. So I'm going to erase the other formulas. I don't need them. So in understanding that the formula stands from, you can find angle L or side L by simply squaring the lengths of the other two sides of the triangle. So I'm going to place N squared plus M squared minus the product of 2MN times cosine of L. So I'm going to go ahead and complete that substitution. So 20 squared equals 24 squared plus 25 squared minus 2 times 24 times 25 times cosine of L. So again, when solving this equation, I'm going to make sure that I evaluate my exponents first. So 20 squared gives me 400. 24 squared gives me 576. 25 squared gives me 625. And then I'm going to take the product, and that's going to give me 1200 times cosine of L. Now I'm going to take the sum first, and that's going to give me 1201. And then I'm going to bring the rest down. 400 minus 1200 times cosine of L. Then, of course, I'm going to subtract 1201 from both sides. And when I do that, I'm going to end up getting negative 801 equals negative 1200 cosine of L. Now I'm going to divide both sides by negative 1200 in order to isolate cosine of L. And I'm going to leave it as 801 divided by 1200. Now remember that negative by negative is going to give me positive. Now when I enter 801 divided by 1200 into my calculator, I'm going to get 0.6675 equals cosine of L. Then I will take the inverse of both sides, which will then give me L equals to inverse cosine of 0.6675. And so L is approximately 48.1 degrees. So if you got 48.1 degrees, you are correct.